In this module, we're going to be looking at configuring network connectivity in the Windows 10 operating system. Of course, today's environments, every system that you have is going to be connected to a network. It's so unlikely that you'd have a system that's not connected to the internet or not connected to a local area network, personal area network, that it's almost difficult to even fathom that happening. So it becomes a very important part of the configuration of Windows 10 as its predecessors to be able to understand how to configure the network and how to troubleshoot the network. And so we have to start at the beginning. We have to start at TCP/IP connectivity, and we're going to look at that. We're going to cover some of the basics of TCP/IP. Both IPv4 and IPv6 are supported in Windows 10, and as a technician, you need to be aware of that. I realize that some of you may already be aware of those things. In that case, I think a good refresher is always a good thing. But we also need to make sure that everybody's on the same page, because Microsoft is most certainly on the exam going to assume certain levels of knowledge, and you'll be presented scenarios where you have to be able to determine IP address configurations and subnet mask and gateways, and they won't always be the simplest scenarios either. So it's very important that we start there. DNS name resolution is also a very important part of today's networks. Internally, it's required for Active Directory. Externally, it's utilized and pretty much required for internet access. So we need to understand how that's going to function. Then we've got a lot of mobile clients. Of course, Windows 10 is an operating system that's meant to be able to be installed across multiple devices. And so we'll take a look at the mobility options, the wireless connectivity settings that you have in Windows 10. We'll take an overview look at remote access, what are the different options for connecting Windows 10 to a corporate workplace, and then finally we'll look at troubleshooting connectivity so that if things don't go right, we have the ability to make the changes that are necessary. The TCP/IP does continue in Windows 10 as the default protocol, as it has been since Windows 2000. It is the standard protocol that's used out on the internet. Transmission control protocol, internet protocol. Technically a suite of protocols or a group of protocols that work together to provide internet connectivity and network communication. So knowledge of IPv4, which is technically the original version of TCP/IP, the one that we've been using for 25 years or so on the internet, and IPv6, the one that is relatively newer, although at this point IPv6 is it's about 15 years old, even though a lot of organizations are not using it internally. But knowledge of those fundamentals is critical for the IT professional because of the things I've already said. You're not going to run into systems that aren't connected to a network very often. There's a basic configuration that's going to be required to connect to a network. What is that? Well, it's the IP address that uniquely identifies that individual host. It's the subnet mask that identifies the portion of the IP address that is in reference to the network segment, and then the portion of the IP address that's in reference to the host ID. We'll see that here in a minute. And then the default gateway. The default gateway is your way off your local network segment. So it's the IP address of a router, typically, that is going to get you to other network segments. In a simple design, the default gateway is just the router address. Everybody has the same gateway. That router connects me to the internet. Okay? But it's possible in larger organizations that you do have routers internally, separate internal subnets, and so the router can then be routing traffic to other remote subnets or out to the internet. And then practically speaking, we need DNS. I mean, for internet purposes, DNS is not technically a requirement for TCP/IP. It just provides name resolution so that you don't have to use the numeric IP addresses, and instead you can use the more user-friendly host names. Okay? But even though it's not technically required, it's practically required because nobody wants to type in 127.16.43.110. They want to type in www.google.com. So name resolution becomes important. And then internally, it's imperative because it's required by Active Directory to locate domain controllers in the Windows domain environment. So, ideally you also then have a DNS server as a part of that basic configuration. Now, mind you, that's just the configuration of the protocol itself. You need the client from Microsoft Networks, you need file and print sharing from Microsoft Networks, and you need a network card. But all of those three things are there by default, and as is the protocol. So we really just need to make sure the protocol is configured correctly. So that leads us to IP addresses. We need to have a little bit of a discussion. This is not everybody's favorite discussion, I realize that. But as I said, a good refresher is always a good thing. And then secondly, this is so important that everybody understands it in order to be able to successfully configure systems as well as troubleshoot those systems. So you have the IP address, which is technically a 32-bit binary number. It's a 32-bit binary number, and binary numbering system is just zeros and ones. But we as humans don't like zeros and ones. We certainly don't like 32 of them all in a line. And so, Microsoft has always used dotted decimal notation, and typically other vendors as well. When we're talking about humans, we write IP addresses, we write it in what's called dotted decimal notation. Each of the numbers has a maximum of 255 and a minimum of 0. Okay? And then you've got basically each of those decimal numbers represents 8 bits. So sometimes you will hear me refer to it as an octet. The first octet is the first number. It's an octet because it is 8 bits. So 4 groups of 8. But technically the IP address is divided into 2 parts. It's divided into network ID and host ID. The analogy I've always used was that of your house address, your postal address. If I'm going to send you a letter, I send the address to, or I send an address to 123 Oak Street in your city, state, and zip. And the postman or the mail person knows to then take it to that street and then look for a particular house number. Part of the address identified the street, the other part identified the house number. It's the same thing with an IP address. Part of it identifies the street, that's the network segment, and the other part identifies the host ID, that's the individual house number, how you're getting it to that host. And it also works similarly because if I had to send a letter and you had 123 Oak Street and the next street over was 123 Maple Street, the mail person is not going to get confused because there are 2 houses and they're both 123 on those 2 different streets. Why? Because it's a different street name. So if the network segment is 192.168.1.0 on one subnet and 2.0 on another subnet, then 2 hosts can be using the same host ID of 100 as long as they're on different network segments. So how do we tell the difference? Well, the subnet mask is what differentiates for us the network ID and the host ID. And so we apply the subnet mask, which is another 32-bit binary number. And it is going to differentiate because unlike the IP address, which can be all combinations of zeros and ones, the subnet mask is contiguous ones followed by contiguous zeros. Okay? So when the ones are on, that means the mask is on, the shield is up, and that part of the IP address that it is shielding is the network ID. Okay, the network portion. Once the ones stop and the zeros start, then we can essentially draw a line because everything to the right of that is the host ID. It's not part of the network segment. And so that's how the subnet mask is going to be used to differentiate. And most of the time, it stops on the decimal points. So your address is 192.168.1.200. You have a subnet mask of 255.255.255.0. So you've got the shield or the mask on for the first 3 octets. That means the network ID is 192.168.1.0. The host ID is 200, whatever's in that last octet. Okay? Most of the time, that's the way that it is, unless you're taking a Microsoft exam. When you're taking Microsoft exams, they love to play around with the numbers. They love to make sure that you know exactly how to do IP addressing and what happens if you have a subnet mask that stops in the middle of an octet, like a 240 or a 224 subnet mask. And so that's where sometimes it takes a little bit of review and just making sure that we all understand this correctly. Most of the networks that we're going to be involved with are local area networks or LANs. These are the networks that are confined to a single geographical area and they're managed by a group of administrators. And most LANs are going to fall under two basic categories, either simple or advanced in their IP configuration. So a simple IP configuration would always be using the private address spaces. The private address spaces are 10, 172.16 through 31, and 192.168. Okay? These are reserved private addresses. And because you're using private addresses, you have a whole lot more flexibility. You don't have to register these addresses. You don't have to pay for them. You have privacy. But it does have a caveat, and that is that you have to use network address translation in order to get out to the internet. In other words, you have to have a device that's got a public address and a private address. And when internal devices try to make a connection to the internet, that device uses its public address to go get the information. Every device on the planet, almost, that's functioning as a router or a firewall, even some switches, are going to have network address translation capabilities. So do Windows servers if you choose to go that route. So it's really not a big issue, and almost everybody uses private addresses. But a simple IP configuration would also use default subnet mask. And those default subnet masks are always going to stop on the decimal points. You've got Class A, which is the 10 network, and the network ID is the first octet only, and that provides 3 octets for host. I mean, technically that provides you something like 16,384,000 some odd addresses in a single network. So that's a huge network. Class B would divide it down the middle, giving you 65,534 available hosts, and then Class C, the first 3 octets are the network, the last octet's the host. That gives you 254 available hosts on a single network. Even that is usually enough for most subnets. And so it does provide various network sizes, and it's simple and easy to use. And practically speaking, most of us are going to find ourselves using that kind of configuration. If you're in a larger network, it is possible that you see an advanced IP configuration. Advanced IP configurations might use public addresses. A lot of them are still going to use private, but the private is not going to be as simplistic. So they'll use one Class A network and they'll divide it up into 32 subnets. And so you're going to use what's called variable length subnetting, VLSM, or variable length subnet masking. VLSM means that the subnet masks do not stop on the decimal points, and the subnet masks for different network segments might not even be the same. So it just kind of depends on how it is. CIDR notation is the norm in these kinds of networks. So as opposed to listing out an IP address and the subnet mask, you'll see the IP address / and then a number. And then that number is the number of bits in the mask that are set to 1. Okay, so it's a different kind of notation. Sometimes this is done out of necessity. I've seen this done out of just, who knows? There didn't appear to be a reason. It was a small network. It was like it was just over-complicating things. So you'll run into that. You'll definitely run into it sometimes on the exam.